Yeah. Able to see the screen?
Yes, sir.
Right. Okay. ठीक है. So now what we'll do is basically we'll have a discussion on here volume is 1800 and this one is like 2280. So obviously our total value will be 2280 LPM is what we have to select as per the pump requirement. You agree?
Yes, sir.
Okay, this is because of the hydrant demand that we have got it. Now, coming to the next element that we have to worry is tank capacities. So, tank capacity, if it is there as per table 7, which is clear for us, we need not worry. If it is not there or if there is any ambiguity, then you can go for as per pump requirements. So, as per pump requirements, if you see, made a slide anyway, that is again a copy from IS code. I'll just read it out so that it will be clear for everyone. This is basically tank capacity, which is there on the clause of 13, which is in IS 15105. Water supply, this shall be noted that water capacity specified in table 30 below are applicable only to those occupancies that are not specifically provided in table 7 of SP7 part 4, which we were referring, or what we have already referred. In this case, we have already got, you agree? In table 7, we've already came to know what is the flow rate that is required, right? I mean, what is the tank
Yes,
capacity?
yes,
So we can blindly follow that.
Okay.
If it were not there, then you have to go to this table 30, which clearly says that minimum you should have 30 minutes for your light hazard, ordinary hazard not like in around 60 minutes, and high storage 120 minutes is the minimum storage time you have to keep. Am I
Okay.
clear?
Yeah, yeah.
So, if table 7 of the data is there, we need not worry. Else only we have to look for it. Understood?
yes,
So in our case, we need not look into this, right? So we've already have a flow rate of around 1 lakh underground tank capacity is what we require. You agree?
yes.
So we can directly go for this 1 lakh liters and we can proceed further. So if it is 1 lakh liters, we'll start with the dimensions. Okay. Now I've just randomly given the numbers here. So here for pump room, there are two important rules that you have to follow or remember. While working on the pump room, one is Vastu anyway, that you have to keep it. So generally we keep it in northeast corner is what you will try to place your underground tank. Okay.
Take it.
Overhead tank. Yes, tell me, sorry. North,
That
south, east, west. Yeah.
that flow rate which we decided was 1800, no?
No. 1800 is
Two
what
two two two
we
eight
got
zero.
it as per sprinkler, but as per hydrant, because minimum 30, like around 30 numbers, we got the hydrants. 20 to 55 as per code, we got around just a sec. Yeah, for 30 hydrants, we
Hydrant.
got 2280 LPM
So this you're telling 2280 into 30 minutes of storage, right? Of 1 hour storage.
for light hazard.
Right? So
Yes.
it is 30 minutes, no?
Yeah.
Okay. We're getting around 68 m cube, 67 liters. So 1 lakh is sufficient for us.
Into 30 is what? Which light hazard? If it is ordinary hazard,
60.
60 you have to take it.
In
Not
that
like that
case,
is. In that case, of course, it's a light hazard anyway. But
hmm,
now we've see first table 7 supersedes all these conditions.
correct.
So if the data is not clearly given in table 7 or if there's any ambiguity, then you'll cross check with us. That is what IS code clearly says.
Okay. Okay.
That's the reason. Understood?
Yeah. Yeah.
And it is clearly mentioned in the clause also. Be like, and if it is not provided, then only you have to refer this data content.
Okay. Which is
Just
IS
telling you
code?
because while
Which
working on some special applications, if you couldn't get, then you can use the script. That's the only reason why I've told you there's something else.
okay. Which is the IS code that tells about this fire sum?
That's what this water capacity is in IS code 15105, which is there.
Same code is it? One
Yeah,
five one.
sprinkler only. They've given even the sprinkler like this capacity as well.
Okay. Okay. Okay.
Yes. Okay. Of course, for underground storage tanks, you have it, but that is not related to the capacity. That's related to the standards that will be taken care of by civil, not us.
Okay. Okay, Chaitanya. Continue.
Okay, fine then. Anyway, We have, so our flow rate was 2280 LPM, if you remember. That is the final flow rate, that final pump capacity. Though IS code is 1620, but as per number of hydrants, at least I require 2280 LPM. Clear?
Yes.
Okay. Then coming to the next element that we have to refer is what is the this thing the other important thing that we have to really worry is this thing what do you call the pump capacities, and so design of location of your pump. So one is vastu, and second thing is to the pump room, entry should be directly from external wherever possible. I mean, if possible, directly from external, anyone should be able to reach to the pump room. You need not enter, try to avoid entry through the building into your pump room. Understood?
Yeah.
I mean, if you want to enter into your pump room, don't enter through the building. Try to provide it from external to the building so that it's easy in case of crisis, which makes
Yeah.
sense, right? Because if there's a fire, obviously, if someone wants to enter into the pump room, might or might not be possible. That's the reason, number one. Or if it is not possible, and due to architectural constraints you cannot do it, then from external to the pump room you should have a separate fire exit path with at least 2 hours of fire rated medium. For example, I'll just give an example. Let's say this is your building, you have it, and this is your staircase, you have it into the building. From external entry or whatever it is, you will have the entry to the building anyway, right?
Yeah.
So if you have a pump room attached to this staircase, say in the basement, you never had any chance. This is your pump room, let's say, and the pump room entry could probably be over here. Let's take an example. And this is if the staircase exit from external. If this is a fire escape exit into your building or into your basement, whatever it is, it's mandatory to have a fire exit path separately for this. 2 hours fire rated, it should be provided.
What
That
is
means it.
Sachana, what is the limitation of the travel distance this from the staircase to the pump room? Is there any limitation on the travel distance?
See that anyway in any building you should reach within 30 meters. Sorry, within 45 meters you should reach any building at the end of the day.
Okay. It cannot, I mean, it should be within 45, is it?
Yeah, your fire exit staircases should always be designed within 45 meters distance.
Okay, understood. So
So
in this
anyway it is there
pathway,
means the maximum travel distance also will be in a similar way. Yes.
so in this
30
pathway,
meters or
nothing.
40 meters depends on the sprinklered and non-sprinklered buildings it is. If it is
Hmm.
non-sprinklered buildings, 30 meters. If it is sprinklered buildings, 1.5 times you can have additional space. So that's the reason. 45
Okay.
meters it will become as.
In this pathway, there should be no any obstruction, right?
There should not be any obstruction, and that pathway, the boundary, the walls also should at least be 2 hours fire rated.
Okay, you should have a clear. Okay, okay. Should we provide any this one year or any preservation year? No, not required, is it?
Stairway pressurization, yes, we will provide it so that we don't want any outside air to enter into this. Yes, we'll
Exactly.
provide
No,
even with federal pressurization also.
there should be no any smoke penetration into this
No
area while.
smoke penetration into this
Yeah,
area. Yes.
noted, noted.
Okay. Fine. So this particular one, if we do it, so we came to know the value is 2280 LPM. So this is so. Anyway, in our case, as it is external to the building, see if you see it, this is entirely the building, right? So from external to the building, there's an entry. Yeah.
Okay. Hmm.
This is a hydrant, we have taken it roughly, but anyway. So this is external to the building. So if anyone can enter into the pump room without a building. So from here, they can enter into this particular one, and then we have to reach to the pump room. So from here, they'll come, and this is the above floor. Just I've showed it in dotted line. That's it. So from here, someone can enter. They'll take a turn like this, and they'll enter, and then they'll reach to this location. Now, what is the height we have to consider from the ground level or the total height of the pump room? So if I want to consider the height of the pump room, so generally as per norms, so each step will be 150 mm, right? Generally.
Yes.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, This is 12 again. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. 45 steps are there totally. You agree?
Yeah.
So for 45 steps, if I calculate 45 into 0.15, that will be in meters. So 6.75 meters, I got it as a total height.
Correct.
Okay. So height is 6.75 meters. And always remember, as per NBC code, you stay, of course, that will be taken care by civil. I'm just giving you for information. After certain around 11 steps, it's mandatory to have a landing. You can't have a continuous steps as well.
So every 11 steps, there should be a landing.
Your
right?
landing, exact number 11. Yeah, 11 steps. At least you should have a landing. Just a second. So remember roughly. Design jobs, GDL. Sorry, Alt. Data. Design jobs to read. NBC, sorry, all data to read. Just a sec. NBC code. Here it's there in your staircase, it will be given. And whether it's this one or ramp structure, I mean, it will be there in civil or this one, I'm not really sure. Landing, right? And okay, our landing wells, it will tell. Just a second. Minimum slope, everything is mandatory. You have to maintain.
Sir, then what about the depth of sump from the fire driveway?
Depth of the dam from
Depth
the
of the sump from the fire driveway.
maximum is 6.5 meters or something. It's written in the NBC code.
Okay, it shouldn't cross 7 meters, right?
Yeah, that's what 6.5 is what we keep as a limitation.
Okay, that is included this lamp post, right? This hydrant.
No, from the road
Made
level.
in electrical post.
From the road level. From the road level.
From the road level itself, it's 6 point. Okay.
Yeah, 6.5 meters. Just a sec. That clause also I'll search and I'll tell you. I'll show you that tomorrow. Height of that tank. Just a second. Okay. Anyway, I'll exactly tell you about the staircase design also. Ramps and staircase design have to distribution of loading of stairs.
4.6.6.
What is it?
4.6.2.
What is 4.6.2?
Depth of
Reference.
clause.
Loud enough.
NBC clause, is it, Chetan?
Yes,
For
sir.
which one?
For staircase.
Okay, 4.6.2. Which one? Obviously it's this one, right? No, that is fire exit staircase, Alva.
Yes, sir.
No, I'm speaking about staircase design. Any staircase for that matter, not only fire exit staircase.
Okay.
Somewhere I'll try to get that because it's related to civil. Because I remember vaguely as 11, because generally when we have a discussion with civil team, will come across these things while designing. But anyway, I'll get back to you on those. I mean, exactly sure 11 or 10, exactly don't remember, but I'll show you once. Okay. Hello.
Yes.
Okay, sir.
Yeah, I'll exactly show, but anyway, that will be taken care by civil engineering, but just for information. If I'm not wrong, some 11 stairs it should be. So now how much distance we got? Around 40 stairs, right? 40 into 0.15. So that's around 6 meters. So out of the 6 meters, again, I'll have some slab thickness that will be lost. Right, at least some, like, because there's a building over here, at least some 200 mm or 300 mm, I lose the slab thickness.
Yes.
So it is minus 6.0 meters, let's consider as of now. Okay. So it is 0.6 meters. So now what we can do here is, so if this is 0.6 meter minus 6 meters, the available height, if you see, offset 6000 mm, that is from road level. Alva? Oh, this is issue with it. Okay, this is an this one, yes. Is a problem with it. Oh, this is in feet. Okay, sorry. 6 meters into 3.28 is how much? 19 feet, 19.68, 19.68 feet. Out of that, at least 1 feet, don't you think I'll have my slab, because this is road level, it will come, pump room means, I'll consider some around 150 mm as a slab thickness. That's nothing but 6 inches. And then along with that, I'll have a beams and beams also could be there around.
Yes. 600 mm.
So other 600 mm, that's offset 2 feet will take it. Yeah, that's including the slab anyway. So this is your effective height. Of course, wherever my pumps are exactly there, will not have a beam. So our effective depth availability will obviously be this one. So if you see this, we have a value of 19.4. But again, it's mandatory for us to have a positive suction. So my pump, this is the floor level of my pump room. But so my slab, don't you think my tank should be at certain raised level or not?
Yes.
Right. So obviously my tank should be at some raised level. So that at least will take around 600 mm like that. Offset 2 feet will take it. So this is the pump floor. This is your flooring of your tank. So the effective height, if you see, this is hardly around 17 feet 4 inches. In that again, around 500 mm, we leave it as a freeboard. That means we don't want any water to be till the brim. Obviously, we'll not connect it, right? So we will have some 600 mm, around half meter, 0.5 meters. We'll keep it as freeboard. So beam marking, I'm removing is not required anyway. So freeboard is half meter. Half meter is how much? 0.5 into 3.28. 1.64. 1.64 feet. You'll keep it as freeboard. There's a water level, maximum water level. What we need to have. So this is a freeboard, we call it as. At least we should have 500 mm. Please remember that. So effective height of water that we have is only 15 feet. You agree? All right. So the value is 15 feet 4 inches. So we'll take approximately 15 feet is equal to 15 divided by 3.28. I'll get 4.5 meters. Understood? So height of water level is 4.57 meters. Clear or not?
Clear, sir.
Okay. So
Chaitanya,
from here,
Chaitanya,
yes, please. Anil.
is there a limitation on the depth of the water?
Yes, it should not be below 6.5 meters, if I'm not wrong. 99% I'm sure that number. But anyway, I'll exactly tomorrow I'll refer you with that particular clause as well. Your height of your tank should not be below 6.5 meters from your finished flow level, from your road level, sorry.
Tank is okay. I'm talking about the water depth.
Yeah, tank depth means obviously it reflects the water depth, alva.
Can we
If
go
the
up to
tank bottom
4.5?
cannot be lesser than 6.5 meters, obviously I can't even have my water level lesser than that, right?
Okay.
I didn't get you. Hello.
Nothing. Carry on.
Okay. You're somewhere. What about your voice is echoing anyway. Okay. So the maximum height that we have is anyway that particular clause. I'll refer it and I'll exactly tell. I'll show you. I mean, I'll correct it if there's any mistake with that particular number of 6.5 meters. Anyway, so when you take this as 4.57 meters, so this particular one is the maximum height that's available for us is 4.57 meters, right? So if it is 4.57 meters as a height, the total volume is how much? 1 lakh liters means how much cubic meter it will be?
100 cubic meter.
100 cubic meters. So your area will be how much? Area is equal to 100 by is equal to
22.4.
100 by 4.57. So it will be 21.86 cubic square meters, right? So I got the volume out of volume is 100 cubic meter. In that, I've divided the height of 4.57 meters height. Then I'll get the area of the tank, which is 21.86. Right or not?
Right, sir.
So I'll divide this area divided by 2. I'll do it so that I'll come to know each tank how much it should be. So it should be 10.99 means around 11 meters I should have it. So 11 meters if I have it, I can use the square of that one. And if you consider it as a rectangle, it's up to us anyway. Oh, sorry. Why is it not coming? Is equal to square root of around 3.3 meters I should have. So 3.3 by 3.3, if I do it, then it will be fine. So if I want to convert into feet into 3.28 again, so that will be around 10.84 feet. 2 such tanks I'll have it. That's the reason I made it divided by 2. Understood? So 10.84, like, width and depth, if I have it, I should have around 2 such tanks. You agree? So I should have around 11 feet by 11 feet. So rectangle dimensions. 11 feet by 11 feet if I take it. So this is the tank dimensions we should have it. Right? This is the volume of the tank. So offset 200 mm. Offset generally 300 sorry 1 feet alva. Offset 1 feet. We'll take it similarly. I'll have a tank again. Am I clear? Just a sec. Offset 1 feet. Take it across. So this particular one, I'll bring it. So this becomes our tank. Understood or not? So
Yeah.
let's say so I need not require this much space, pump room. I need not require that much. So probably, I mean, this my ending wall could just be this one, right? So this one will take it across like this. Then according to your domestic demand, you can have domestic tank as well. You agree?
Okay. Yeah, yeah.
Okay, so this we can keep it this. So this is our fire tank. So this entire thing, I mean, here we can have our pumps and all. So your fire pumps and all, you can keep it over here. Am I clear?
Yes, yes.
And as per code, you can't even, of course, this particular code, many people wouldn't use it, but technically, any other services, you shouldn't have it inside your pump room, including plumbing. But yeah, you will see generally in fire pump room, you will keep your plumbing pumps, your hydromatic system, everything will be there. You will
Yeah.
clearly say, yes, you were telling something. Sorry.
Now, generally, what we do here also is that we made a clear partition.
Yeah, that's what. Technically, you have to make it, but in many tech parks or wherever you see that particular one is not, that philosophy is not followed.
Okay. Okay.
Technically, yes, you should have a partition with a separate fire rated, like, walls. And it should be a fire, like, your fire door.
Okay.
Understood? Anyway, I mean, for that reason, we'll ask for a partition. But anyway, in many cases, what will happen is because that's 6.5 meters height, alva. So that's a civil structure. It will be higher by karke. They'll not do it. Just stupid. But as per rules, you have to. That's what I meant to say. I did ask you to ignore, by the way.
Okay, okay.
Okay. So this is your final wall structure that you have got it. Yeah. So this is your pump room, and here you'll have your domestic, which will be interconnected to your fire. So now this particular one, we have to worry about your pump room design. So in this case now, we'll understand the schematic, how we're gonna do. So roughly, we have placed the sprinklers. We have placed your hydrants everywhere, isn't it, to calculate the number of hydrants? Yes or no?
Yes.
So this is your internal hydrants. So similarly, we'll have your external hydrants also. So for external hydrants, we will take it from here. So now the pipe output, how will it come as a question? So pipe output, how could it come? So first and foremost thing is this particular rectangle. Now imagine this as your room space, let's say. This is your room space. Let's take this as your room space. I'll move it from here to here. So this entirely is your room space. You agree? Pump room, to be precise. So obviously, I can't take it at this location. I can't take it after this location. I'll not be able to take it. So the better option is we will take the pipe outside from here so that at this location, the pipe will come out or not, which will be connected to all the pipings. Yes?
Yes.
So what we're going to do is, I mean, for us to understand how the pipe is going to come out, basically, obviously, I can't take it inside the building. So what we're going to do, we will take the pipe at this location, or I can take it at this location. It's up to us. Here you can take it out, or here also you can take it out, external to the building, right? So somewhere over here, I can easily take the pipe which is out. Understood?
Okay.
I mean, anywhere after this point, I can take it. So we'll take the pump outlet. Now we have to place our pumps. We have to place valves and all. I'm not teaching you because you guys are already aware, like NRV, butterfly valve, all those things, right? From
Yeah,
your
yeah.
plumbing system. So I don't want to deal much into that anyway. So the basic schematic will just a second. Yeah. So now what we're going to do is we'll be working on one simple element, which is basically understanding the piping. So from here, the pump will be connected in this fashion. So from here, we'll have a pump network in this. So we will have multiple, we'll have two common thing, which will be connected to a common suction manifold. From the suction manifold, it will be connected to pumps. In our case, how many pumps we'll have? In the pump room, how many pumps we'll have it in our case?
Three.
We'll have three pumps, Alva. Yeah, one hydrant, one hydrant and sprinkler is one electrical pump in our case. It's not two separate pumps, right?
Okay.
If you remember requirement sheet, if you take it, it's one electrical plus one diesel. We have it, which is of 2280 LPM instead of 1620, and then we have got a jockey pump. Only three pumps we have it, right?
Okay.
So we have three pumps here. Pipe sizing and all, you guys are already aware, right? So we have three pumps which are connected. So I'm just showing you schematic as such. So I'm not going in depth of that as you're aware of the thing. So basically we have your, what is the FPS you'll generally design? Or what is the velocity with which you design the pipe sizing?
1.5 we take
1.5 meter per second, is it?
per second, yes.
1.5 into 3.8. Suction is how much? Discharge is how much?
Suction velocity is very less now. You don't get so much of velocity. It's only
Actually,
a discharge. We're talking discuss about can you consider only discharge of 1.5.
Okay,
Suction
discharge
hardly
can
one.
go even up to like 2 as well, right? 2.5 also you can consider it, right?
You
Only
can
thing
go
is
up
your
to 2
friction
point.
factor should not be more than 4 feet per 100 feet.
Yeah, you can go to 2.4. Yes.
Yeah, 2.4. So suction generally we take around generally 4 FPS is what we take it. 4
Mhm.
FPS. So 4 divided by 3.28 if you do it around the 1.2. That should be fine. Along with that, we have got a small slide. I've given it somewhere. Remember, just a second. Pumps. Sizes also, they gave the approximate sizes. Yeah, these are the basic sizes that you'll follow. According to your flow rate, your suction and delivery sizes also, we have it over here. That is for pump, but anyway, when you do your velocity method, you will get a similar sizes.
Okay, but this quantity is not given, no? Just one quantity is there. It's because it says suction delivery
For each pump,
for each pump, is it? Okay. This is also IS code
for the
3844.
header. Yeah, 344 it is given. Yes. Okay.
Yeah.
If this is the minimum size, you can increase more than this size. No one's gonna say anything at all. Yeah.
Okay.
Of course, when we do our velocity, we'll come back to this number only at the end of the day. So it doesn't make a difference. Fine. So now we have these pumps that we have it. So from these pumps, so at the end, basically here you'll have an isolation valve. I mean, instead of compared to butterfly valve, I would prefer sluice valve because you have a high head, right? You have large volume of water that's coming. So I'll always prefer sluice valve in the main line. So here you select one sluice valve. Here you'll select one sluice valve. Let's take the numbers. Just a second. So I'm ignoring the pipe sizing and all. Is it okay? I'm assuming that you've already worked enough on that particular ones.
Hmm.
Is it fine or you want me to teach that as well? Yes, please speak out.
Chetan,
Yes.
Sir.
in pipes ಬೇಕಾ?
ಇಲ್ಲ ಇಲ್ಲ ಸರ್.
ಬೇಕಿದ್ರೆ ಹೇಳು, ಏನ್ ಮಾಡ್ತಾರೆ, ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ.
Hey, well, that's fine. If you want, I'll teach, or because you guys are already plumbing consultants, that's the reason I don't want you to stress on that. That's the reason. Nothing else as such. So we have got electrical pump, jockey pump, and diesel pump, and these
Sir.
two pumps. Yes, tell me.
Yeah, sir, you just go through these pipe sizes also so that we will correlate it.
Sure, no problem. That's what I asked. If you want, I can teach you that, not a problem. Okay. So I'll just teach in a single line. Is it okay, or you want me to make a proper double line pump figure everything you want me to show?
No, single engine.
Single line is
Single
okay.
line for is fine. No? Okay. So first and foremost thing is because after this we'll have a discussion on puddle flange locations, which is really important for us. Anyway, first we'll continue on this. So here the flow rate that we require is 2280 LPM. Alva?
Yeah.
So the flow rate is 2280 LPM. So when this flow rate is 2280 LPM, the maximum flow rate, how much it can happen in the inside your suction manifold or discharge manifold at any point of time? It's 2280 LPM only. The reason is when jockey pump is running, your diesel, okay, there is something called as a sequence of operations. So here you have three pumps, right? One is jockey pump, diesel pump, electrical pump. It could be of any order. There is no rule that first it should be diesel pump, first it should be jockey pump. There's no such rules as such. Yeah. So when I have this jockey pump, electrical pump, and diesel pump, first of all, for lower flow rates, if there is one sprinkler leakage or someone have opened your hose reel drum, your first aid hose reel, what you meant to say. So at that particular point, you have very low leakages. In that case, first your jockey pump will come into picture. The jockey pump is unable to handle the pressure drop. That means suddenly someone have opened the hydrant valve when the flow rate is very high. Then your electrical pump will start running. Your electrical pump flow rate is how much? 2280 LPM. Jockey pump is only 180 LPM. The minute you are pushing 2280 LPM, don't you think the pressure will be sufficient or not?
Yeah. Yes.
your jockey pump will stop running then. If electrical failure is there, and then your diesel pump will come into picture. Understood?
Everything is automatic, is it?
Yes, jockey pump is auto on and auto off. Electrical and diesel pump are auto on and manual off.
Okay. Jockey is auto on, auto off. The electrical and diesel are auto on and manual off.
Yes. Okay. So when you have this particular one, so generally what we do is according to the pressure we'll calculate it. So that once after we design, we'll come back to what pressure we have to keep the switch on and off. Am I clear?
Yeah.
But anyway, by default is 9, you take it, around 8.5 or 9, you take it, and 90 meters head, you'll take anyway your pump selections. So you'll take around 8.5, you will switch on your jockey pump at 7.5 and you will switch off at 8 or 8.5. And 5.5, you'll switch on your electrical pump. Your 4.5, you'll switch on your diesel pump. These are the general settings, no matter what you do, at least as per Indian codes. Understood?
Yeah.
But anyway, let's go into it later. So here, at any point of time now, how many pumps will be running?
One.
One pump. So what is the flow rate?
2280.
So don't you think my entire suction manifold also I can design it with 2280 LPM or not?
Yes, yes, yes.
But worst case, if you see, there is a minor value where your
Jockey.
electrical pump and jockey pump can
Jockey.
simultaneously run for very short duration.
Yes. Yes.
Right? So for safety, we can take that value. So 2280 plus 180 LPM.
80. Yeah.
So your flow rate design should be for this particular one. So here the suction manifold, whatever is there, the suction manifold will be 2280 plus 180. But again, a lot of consultants will consider only 2280, 2460 LPM. So 2460 LPM, we can take your FPS as 4 FPS as your suction velocity. Discharge could be 6 or 8. So obviously we can use this tool. So temperature will be 70 °F water. And what is the flow rate that we have it?
2640.
2460.
240.
This is LPM. So if you want it in GPM, how much will it be? This value divided by 3.78?
3.78. Yeah.
650 GPM. So we'll take this value as 650 GPM. Diameter will probably be 6 inches. Is how much? 650. Okay, the velocity is a bit higher, which is the 7.22 FPS. So it's better we take around 200 mm dia. 8 inches, 650. Your velocity is 4.17, which is fine for us.
How
4
much?
FPS is your suction velocity.
How much it comes in meter per second? Chaitanya, that is just I'm just checking.
Is equal to 4.17 divided by 3.28. Yeah, 1.2. I said no, 1.2 will be suction and the discharge could be 2.4.
Okay. Anything
Yeah.
that we have to do is the velocity should we keep 1.2 only, 1 only. So what is the minimum velocity we'll keep for suction, Chaitanya?
That's a minimum velocity that we see. Two conditions. One is generally suction side. You design it with 150. Your 4 feet per. I mean, I am generally comfortable with FPS. That's the reason. I came from the HPC background. That's the reason.
But 1.2
But anyway,
is it?
yeah, around 1.2 or 1.3, you can take it.
And delivery?
Delivery will be around 8 FPS velocity. So
Double
it's
of that,
equal to 8 divided by 3.28. So around 2.4.
Okay.
That's the
Okay.
highest, but make sure your friction factor is not more than 4 feet per 100 feet.
Okay.
Whatever condition it is, your friction factor should never be greater than 4 feet per 100 feet.
Okay.
So this value will be 1.2713. So this value will be 1.2713 as your this thing. But anyway, the pipe size is 200 mm dia is what I'll require. You agree? So the diameter of the pipe size is suction manifold is 200 mm dia. See, because the drawing is in inches, I'm just drawing it in inches. Is it fine? This one will take it. And coming to the next one is, what is the flow rate that we have it? What is the flow rate that we have it for each pump? 2280 LPM alva. So 2280 LPM will take it. So directly we'll take 2280. 2280 LPM means it will be 603. So 603 means 603. 603 will take it. 603. So here the velocity is 6.7. It has come. So I'll obviously select this also as 200 only. Understood? Because I don't generally will not increase more than 1.2 or I mean around 4 feet per 100 feet. So I'll take 8 inches pipe size as well, even for this. Is it fine? But as per this one, minimum I should have is 150. So I'm providing more than 150. We're happy with that. If you provide 150 also, no one can say anything. But yeah, generally we try to limit the velocity of suction for lesser turbulence and all. For that reason, we'll take it as 200 mm dia in this case. Am I clear or not?
Clear.
So we have to take it as 200 diameter is what I will choose. So this entire thing will be 200 diameter. This will also be 200 diameter. This will also be 200 and this will also be 200 mm diameter. But whereas this particular pipe says jockey pump, it is only 180 alva. So
180.
180 LPM means it will be 47. 47. Generally, if you take 2 inches, all should be sufficient. 2 inches to 3 inches pipe. 47. It is coming to 4.49. So 50 mm means we'll take 65 mm dia. Is
Yes.
it okay? Then
Yes.
definitely it will be 4. So we'll take 65 mm dia. 65 divided by 25.4 is 2.55 inches. So 2.5 inches dia is what we'll mark it here. So this dia will be 2.5 inches. Clear? Then we have to really worry about the next one, which is your discharge. Your discharge velocities will be around 8 FPS velocities. So your discharge manifold could be even 6 inches as well, let's say. So the flow rate is how much again? 2280 plus 180 alva.
2460.
Yeah, 2460, so 650. So if it is 650 again, we'll start with 6 inches. How much is it? 650 alva. 650. So 650 if you take it, it is 7.22 and friction factor is 2.68, only well below 4 feet per 100 feet. So we are fine with that, right? So don't you think I can go for a 6 inches diameter? So your discharge manifold is 6 inches. Am I clear?
Mhm.
And obviously this thing also should be 6 inches because IS code have said, and obviously when we calculate also we'll get the same value. Understood? So both these things will be 6 inches. And this one, it will probably be 2 inches. Let's see how it goes. So what is the value? This is 180 LPM alva. 180 means 47.67. So this is 47. And this value could be 2 inches as well. .49, but we might even consider 1.5 inch. But again, IS code will come into picture. Here it said for 180 LPM is not given, is it? In this case.
It's not.
Okay, then we can choose whatever we want to as per the velocities. So in this case, this is 47 LPM means you can consider
1.5.
1.5. Sorry, 1.5. What is the size?
This one.
What is the flow rate? 47
47.
alva. 47, 7.41. So we can either go for 2 inches or 1.5 inch. Clear?
Okay.
So 1.5 inch means it will be how much? 32 mm dia, right?
40.
Oh, 40 mm, sorry. So either we'll go for 40 mm or 50 mm dia. Safety will generally consider 50 mm, 2 inches is safer to consider, but yeah, you can go for 40 mm also, nothing wrong with that. Is it fine?
Yeah.
Yeah. So this is your 2 inches diameter. You have got it. So these are the pipe sizes. If you've got it. Now we have to really worry about your common discharge manifold that will be connected. So when the discharge itself is 6 inches, you need not select higher than that. We can directly choose your 150 mm diameter pipe that will be coming out of it. Understood?
Okay.
Okay. So from here, we will choose your 150 mm diameter pipe that can come out through this element. I'll take it at this location. At this location, we'll take the pump outside. Diameter 150 mm. Sorry, this is in feet, right? Most of the drawings will be in mm anyway, most of the cases. So we got this particular pipe, which is again 6 inches diameter. Am I clear or not?
Yeah.
So from here, the pipe will come out at this location. The pipe will come out at this location. From here, the pipe is going to run around the building. I mean, this is the demarcation of the building. That's it, nothing else. Demarcation of the pump room. So from here, the pipe will come out and then it will be connected to your ring main. And then we will connect it to multiple yard hydrants and then to internal hydrant system as well, to your sprinkler system as well. Understood?
Only one line will run, is it? And sprinkler line won't run, is it? Only one line, is it?
If I want, I can take 2 separate lines also. If I want, I can take 1 single line as well. If I take 2 separate lines, we can isolate it from internal to the pump room itself. If it is externally, if I want to do it, then we have to give valves at that particular locations.
But by taking one line, how do you isolate the sprinkler hydrant, which we
That's
discussed
what I said. That's the reason I said we have to do it from the external of the building.
Hmm.
Let's take, this is the building that we have it. This is your ring main.
Hmm.
You can take 2 pipes also. 1 pipe as well. It's up to you. It should solve the purpose. Let's say this is my external yard hydrant I've just run just for the roughly. We'll take exact dimensions. We'll do it later. Now, I have to have 2 or 3 different zones in this case, right? Because each zone of sprinkler system, how much I cannot have more than 1 sprinkler system cannot be suited to how much area? More than not more than 32,000 square feet, alva.
Oh,
So if it is not more than 32,000 SFT, I have to take the total area and then I have to divide it. So let's take the area approximately. I mean, I'm roughly doing it because it can vary too much. Let's take this area. All the outputs is equal to this. If I take it also, of course, we'll draw a polyline on this way. So that's better. Of course, I did not take that whole also, but in this case, I'm just doing it for this. So this is my area, alva. Building is weird. I can't help it in this case. Anyway, this entire thing, I'll take it as a separate landing. Okay. So anyway, don't worry. That entire thing, I'll take it as a separate zone. Because I can't take it from every room, we can't take it. So I'll have a separate razor for that. And then for that independent building structure type, whatever we have. See. So what is the area we got? 35,000 square feet we got it, right?
hmm.
Yeah. But in case of ordinary hazard, it's 40,000, just like 4,000 square meters, if I'm not wrong. Just a second. Sprinkler pump capacity, I have the zone. Yeah. So if you consider ordinary hazard, it is 4830 square meters I can have, right?
Yeah.
So 4830 square meters means how much is it? Is equal to 4830 into 10.76. So that's around 51,000 I can have it. But now area of each floor is how much in this case?
35.
It's 35,000. So 35,000 means is equal to 35.7. So 36 I'll take it for my rough estimation. 36,000 I have to take it. So, but how many such floors are there? 1, 2, and then I've got this area also which I have to protect. Yes or no?
Yes, yes.
So if you take it, so probably I will require is equal to this into 2 is 72,000, plus we have to take this area also.
Around 15.
15, just a second. Of calculations. Pump room is probably not required because if the area is lesser than 200 square meters, then it's not required to have a sprinkler system. Moreover, it's completely external, so it's not mandatory. So what is the area? 9842. Right, 9,842. 9,842 square feet. So if you add together, it will be 81.84 is equal to sum of all these elements. So 81 means, don't you think at least I should have 2 zones or not?
Yes, yes. At least 2 zones, yes.
At least I should have 2 zones for
2
sure,
zones.
right? So at least we'll have 2 zones of sprinklers for sure, right? So if I have 2 zones of sprinklers and this independent building, I'll take it as a separate zone.
Okay.
So at least 3 zones I'll have it. Let's take, for example, let's say one sprinkler pipe, I have given it at this location. I mean, one hydrant valve or something, I've given it from this location. Let's take as an example. Okay. So in that case, what will happen is at this location, if we try to do it, like, if we want to do it over here, then one piping, I'll connect it from here to here. From external ring main, I have to connect it, alva, somehow or the other. Yes or no?
Yes,
From
yes.
the external, I have to connect it to this guy over here.
Yes, yes, yes. You
Right.
have to. Mm.
And I mean, let me assume this is one zone I've considered, and this probably is one more zone. So, of course, we have to locate your hydrant location that will decide anyway. So, if we have this one, so from let's say at this location, I wanted to have one more zone standpipe. So, here we'll have it, here we'll have it. Then what we are going to do, we will provide an alarm valve at this location, and then we'll provide an isolation valve at this location. External to the building, you will provide all these provisions. Understood?
Alarm valve only for that zone, or how is it meant together?
No, for this zone also, you'll have a separate alarm valve. For this zone also, you'll have a separate alarm valve.
Okay, okay, okay.
But you will provide isolation valve and alarm valve, especially at least isolation valve external to the building, so that firemen can come and external to the building, you can operate that valve. Understood? You'll isolate it manually from outside. Understood?
Can we combine zones and put isolation in this one alarm wall, or now we have got
No, each zone should have its own alarm valve.
Okay, now in this case we'll have 3 alarm valves.
3 alarm valves. Yes,
Yeah.
one for this, or I can even split it into one more also. Because if I feel like, instead of all those headache of taking the pipe throughout the rooms, it will be tough. Probably I can introduce one more zone as well, right?
No,
Because
we
this
have
is the
like
minimum number of zones. I can have more number of zones also, right? Yeah.
But it's only adding to your cost. No, I mean with 3 zones we can manage, right?
You can manage, but cost is two way of looking at it. So you have to take care of everything. So if you don't split it, what will happen? Your horizontal pipe length will increase, Alva. I mean, your main pipe sizes and all also will change.
But now, since you want to add one more zone, how do you add that zone? Now, as of now, we have made for 3 zones, right? One more zone, how do you manage that? I mean, how do you
We'll add
do?
one more alarm valve, ಅಷ್ಟೇ ಅಲ್ವಾ? And we have to add one more razor pipe.
Okay.
That's it. What's a big deal with that? Clear?
Yes,
Hello?
yes.
Yeah. So with that, basically, so we have to provide your alarm valve external to the building. Am I clear?
Okay.
Okay. So like that, we have to always provide it for any you'll provide an alarm valve external to the building. So when you provide in that case, you need not provide it in the pump room. Else, you have to take one particular pipe for hydrant and one particular pipe for sprinklers, and then you provide isolation valve inside your pump room only. Hello?
Yes,
Okay.
yes.
You can take two separate pipes from the delivery manifold if you want. Okay.
Okay,
But
okay.
that is generally done when you have two separate pump systems. When you have a separate sprinkler pump and hydrant pump, then you exercise that. Understood?
Yeah.
Yeah. Okay. Now, when we have this particular element, now what we're going to do is we have to worry about your first we'll complete yard hydrant and then we'll complete we'll work on the sprinkler system. That's
Yes, yeah.
fine.
Yeah.
So we'll take this as your okay. This is your pump. Oh, this is your sprinkler outlet that you have got it. So we'll take external hydrant. Okay, this is approximately we got it anyway. So as I've told you, you should have a gap of either 6 meters or 2 meters around the building. I mean, minimum from 2 meters, you can have like, from 2 meters to, you can have up to that's what, 15
12
meters
or
you can have a gap.
16 meters. you probably have
15 meters you can have it.
15, yeah.
Right. So in this case, let's say we have got a path and all around. So shall we take around 2 meters distance and let's say then we have got a fire drive of 6 meters?
Yeah,
It
yeah.
depends on the architecture that solely just according to the building, you can't take it as such. So what we'll do is we'll take approximately a gap of some 2 meters. So this distance should at least be 2 meters. So 2 meters means how many feet? 2 into 3.28 alva? 6.56 feet.
12.
6.56 feet. We'll take this as your total hydrant system. At few locations, it might be underground also because obviously the entry, we don't want it, right? Or entirely also, it could be underground. It's up to you. Clear?
Okay.
So at this particular location, let's say we wanted to place our hydrant valves. So first of all, I have to join this pipe to this pipe or not? So this is our outlet pipe that's coming from your manifold.
Okay.
So from here to here, we'll take this particular pipe, which is connected to this location. So automatically, this pipe will automatically be 150 mm.
Hmm. Yes.
This entire thing will take it as 150 mm. And if you have a ring main, if you have, as per NFPA, the rules are slightly different. If it's a common pipe that is both serving sprinkler and hydrant, at least it should be 200 mm.
Okay.
Okay, 150 you can't use it, but as per IS codes, there's no such rules. So as per NBC, you can have 150 mm both serving for sprinkler as well as your hydrant system.
Okay.
Okay, but
Yeah.
only thing is number of hydrants. If it is only like if you have more than one hydrant valve, if you have two hydrant valves, minimum of 80 dia you should use. But if you sorry, one dia, one is 80. Two is 100. If you have more than two hydrants connected to the system, at least you should have 150 mm dia.
Okay.
You can't decrease lesser than 150 mm dia. Clear?
Yes, yes.
If I'm not wrong, you've given that also in slides somewhere. Let me see. Just a sec for hydrants. Else I'll add that as well. Yeah.
This is not
Tell me.
shared now. What is presenting now?
This is not actually, this is not a presentation. I'd say that's basically I've taken a snapshot from your eyes. Good, but I'll share you this actually.
Okay.
These are basically the landing wells that you should have, either 100 mm, like single landing well or double landing well, you'll have it. Okay, I'll exactly show you that as well. But anyway, I mean, you have that in IS codes, which I can show you a snapshot of. 150 mm dia is what we have it in this case. Okay. Now coming to the landing valve, the type of landing valves that we have it. Okay. So if you see your landing valve that you have it, your external landing valve, you were generally for like, storage buildings only, you have your double, or if you have very high buildings only, then you'll go for your double headed hydrant valves, or else single headed hydrant valve is sufficient. Understood?
Okay.
This you can see it. In this particular one, you can see 100 mm single outlet landing valve is sufficient for the following areas. Okay. R is institutional, alva. For all institutional buildings also, we can have your single-headed hydrant valve. Yeah, you need not have double-headed. Yeah. So now in this case, first of all, we have to place your hydrant valve. So for that, for external hydrant valve, you've got a thing which is the distances. So here, at least one hydrant post shall be provided for every 60 meters of external wall measurement in case of light hazard occupancy. For every 45 meters in case of ordinary hazard, and for every 30 meters in case of this one, extra hazard area. Now, what is our hazard? Light, ordinary, or extra hazard?
This is light.
Light hazard. So we can have a distance of 60 meters. Am I clear?
Yeah.
So the total length you take it, less you take it here. So what is the total length you have got it? 1082 feet. So 1082 feet is the total length you got it. So 1082 feet, if you take it, that is how many meters? Is it complete then? Yeah. 1082 feet. So is equal to 1082 divided by 3.28. That's around 329.88. So is equal to divided by 60 meters. Andre 5.4. So around 6 or 7 we can have it or not?
Yeah, 6.
6 or 7 external hydrants we can have it. So we'll take 7 external hydrants, we can take it. So I can divide this entire length by 8 or 8 divided by 8 or
Yeah.
7?
7.
7. So totally I'll come to know that at these locations roughly I'll place my yard hydrants. Is it fine?
Yeah.
So I've taken a block already. So this block I'll directly place it to the building. If it is 15 meters, we'll try to push it away, we'll try to push it away from the building. We'll take it a bit on the side. That's okay. Huh? Of course, you just cross check whether you got the distance or not. That's one more thing. Yeah. So here I'll place it. This is also the location where I can place a hydrant. By the way, instead of telling you rules directly while working on the project, I'm explaining you're comfortable with this approach, right?
Yes, sir.
Yes.
So external to the 90 degrees or whatever. So I might have to place it elsewhere over here. We have it at this location. Right, I guess this distance is long. So how many we got it? 1, 2, 3, 4, 5, 6, 7 are there, which is sufficient for us. So we have placed it at a distance of 60 meters approximately. You agree? Yeah.
Yes.
So this becomes our yard hydrant circuit. Simple. Select supply. So we've got our yard hydrant circuits. I'll just make it with different color for ease. I'll make this as orange mode. Okay. This is our yard hydrant network. But now from the yard hydrant, I have to connect it to this. You agree? Yeah.
Yes, sir.
So we made this particular pipe, which is also a 6 inches diameter. So we've got a pipe that is running around the building. It could be underground or overhead, depending upon your site conditions. Clear?
Yeah.
Clear.
Now we will work on the internal hydrants from tomorrow again. Is it fine? So probably other 2 days we might be able to complete this session. So I mean this particular building especially. So what we're going to do is basically we will be working on sprinkler system entirely. First, we'll place all the internal hydrants, and then we'll work again on the sprinkler locations. Is it fine?
Yes, sir.
Yeah,
Yeah.
Jaswin.
So tomorrow again we'll continue because I don't want to stop again for internal hydrant. That's the reason.
Yes, sir. We can continue.
Okay. So we'll continue again tomorrow. We'll connect back. Okay. Take care, guys. And tomorrow we'll continue again at morning 5:30.
Okay.
Bye bye. Any queries? You're free to let me. I'll add that snaps also, and then I'll share you this particular PPT. Yeah. Take care.